Hey everyone, hello. Thank you for joining and welcome to our episode 2 of the Old Guard. I'm very glad that you guys were able to join us. I was hoping Twitter Space works on desktop. That's one of the reasons I delayed. I was trying to get it to work on my desktop. Kind of holding the phone or trying to use the earphones is usually a bit of a challenge. But I realized that is not the case. So they still don't support desktop. But no worries. Thank you guys for joining. So today's space is on computer security. I had considerations for canceling this space actually because our speaker that I was counting on is not going to be able to make it. But then I thought, okay, I mean, if that's the case, then we'll be canceling a lot of spaces because of speakers not showing up. So I think we'll just go ahead. But it's understandable. It's somebody who is in like a different time zone, and I'm guessing they probably haven't even woken up by now. So maybe they just overslept or something. But that's okay. So we'll just proceed. And since my planned speaker won't be able to show, I think if any of you in the audience would like to speak on the topic, just request the mic. I would just go ahead and pick a few guys, but that would be unfair. So I don't know which plans you had for today. So you can just request the mic and join in the discussion. Otherwise, my plan is to just do an overview, kind of share what I know, hopefully trigger a bit of a discussion from what I share, and then we can pick it up from there. And since we are doing a computer security discussion, there are some interesting events that happened, or maybe event that happened in the past few weeks. So there's this casino chain, a chain of casinos in the US called MGM. So they recently got a really serious cyber attack. It was a ransomware attack. Of course, they were asked to pay. They refused to pay for a while, and then the hackers managed to put them out of business for, I think, a couple of days. I was seeing the story up on Mental Outlaws YouTube channel. He kind of covered it. So it's an interesting thing that happened that's kind of related to what we are going to discuss today. So my plan was to have a computer security professional kind of lead this discussion because, as software developers, that's not really our strong suit. Of course, we have to consider particular security practices in engineering, but there are people who are kind of paid to do that. If you're in a large enough organization, of course, if you're in a small company, you have to wear multiple hats. So that's why I went to the Kenyan catch the flag community, if I can call them that, the computer security professionals that I've seen on the TL, but they seem to be really engaged. So I was not able to get any of them to join us, and the one who agreed to join us seems to be caught up on something. So regardless, I think we'll just proceed. So first, I think I'll give a few minutes if anybody wants to speak on this topic. If you know something about computer security that you would be interested to share with the community or with the space, feel free to request the mic or raise your hand, whatever works, so that I can invite you on. Otherwise, I think I'll just go ahead and introduce the topic that we're covering today, and then we can pick it up from there. Computer security. I think the best place to start with this is, why does it matter? Because, as software developers, our main focus is usually to build software. So security just becomes one of those secondary needs because, your primary focus is to build a product that customers can use. But of course, quickly you realize down the line that, security starts to become important, especially if you're handling customer data, or if you have some IP you want to protect, or some trade secret. Maybe your business model is based on secrecy. So if somebody figures out how you do some particular workflow, then they can kind of replicate that, and your your company or the organization you work for might end up losing business because of that. So there are multiple motivations for computer security, and one of them, just like I mentioned earlier, is once you have to start to acquire customers, and especially when customers start to share their data, because we work in information technology, so there'll definitely be some stream of data coming from the customer to the service to your internal services. So, and more often than not, that happens to be sensitive data. And any form of data currently, we live in a data age, so any form of data is valuable. So you'll definitely find yourself in a case where the data that's being provided by customers quickly becomes sensitive. And even as a software developer, you start to think about maybe I need to start thinking about how to secure this data. So, and your motivations will be, one, to secure the privacy of your data, of your customers, and two, to maintain customer trust. Because if customers are afraid that your service could be hacked tomorrow, and everything they are sharing on maybe the site or the app becomes exposed or gets into the hands of hackers or criminals, then they'll start to worry. Especially if you're in the space of like maybe fintech, and you are collecting maybe banking information, people's bank account records. You start to worry about how to make sure that this data is safe for the customer to maintain their trust in you, and at the same time for you to be able to deliver a service that they are happy to continue using. In the back of their mind, knowing that you've secured their data. Of course, the other one that also it's common, I think, in the fintech space is compliance, and this will comes with the government. And if you are running on the back end of some larger service provider, maybe like a payment service. Good example here would be Stripe. So I'm sure if you integrate with Stripe, there's some security compliance requirements that they require that should be available on your backend before you integrate with them. So another security need would be the compliance requirement. And that the compliance could be you're running on somebody's backend, and they're like, okay, if you're going to use our service, your servers need to meet this level of security, or you need to have these security protocols in place. The other one would be a legal obligation. Maybe central bank is like, okay, so you want to run a customer wallet and you want to do financial transactions on your service or hold customer funds. You have to meet this particular level of security, and you have to prove it to us that you're able to provide that level of security. So that's under compliance and legal. The other one, which is a major motivation, I think, for managers and owners of companies, is financial losses. So, like the MGM case that I told you guys about, where these guys got a cyber attack. It was a ransomware attack, and they ran a chain of casinos. So the places where like people gamble, most of those if I can call them terminals or endpoints that people interface with the gambling machines, kind of were shut down, so they were not able to do any business. So that duration where they were offline and they were not available, and they were not able to provide the service that they provide their customers, they were experiencing financial losses from revenue. Of course, eventually they had to pay the ransom, so that marks another level of financial loss, because now they have to pay these hackers money so that they're able to get their business back. So that's one other motivation. Of course, like I mentioned, intellectual property and trade secrets. You don't want your competitors figuring out, that new schematic that you guys came up with for the next line of products. So you might really need to establish some securities that the intellectual property within the organization is safeguarded and protected. Of course, the main one here is reputation damage. So, like the MGM case, being that they were able to be attacked, and customer data was stolen, and with hackers, even if you pay the ransom, the customer data could still be available in some a dark web site somewhere, and they usually have these databases backed up, and they put them out for sale. And although you already paid the ransom, these guys are still making money from the database, especially if it's a recent database record. And for a company that's like running a chain of casinos and stuff like that, you can imagine the kind of data they have. So in the black market, there will be somebody interested in buying that data. So that creates a reputational damage. So the next time, the big wigs from Dubai want to go to Las Vegas to, have a good time, they'll probably avoid that particular casino because maybe they don't want people to know that they were there. So the reputational damage is also something to consider. The one that's I think usually dangerous, and Microsoft experiences this a lot, is when somebody does an attack and they don't make it obvious. So they just sit within your system, monitor the traffic, and when they get the opportunity, they either do a denial of service attack, or they just take the data or interfere with the data that you have running through your systems, and then you end up having situations where you have data tampering. We used to make this joke back in campus. I don't know if anybody pulled it off, and it was about hacking into the university's ERP system and changing your course scores. There were these legends of people who managed to do it, but I doubt anybody was able to do it. I don't think we had the expertise to be able to pull that off. But I think within Kenya, that was mostly financial loss. I think KRA has had multiple cases where they got attacked, and the hackers managed to steal money somehow. But sophisticated hackers will just get in there, interfere with your data, maybe change a few records here and there, and then they get out. So before you notice, it has caused a cascading negative effect in the provision of services. So that's another thing that could happen. So there are multiple motivations for considering computer security, especially for software engineers. And I think it's something that most of us think about. The moment you develop that login page, and you're asking somebody for their username and password, you already think about, okay, how can I safely store these passwords so that it's not exposed or it's not accessed by a threat actor or something like that. So it's something that's usually in the back of our minds. And the motivations, just like I mentioned, are some of the few that I've mentioned, but also the other motivations that arise, either driven by legal compliance issues or by the organization's policies, or just the desire to provide a good service to customers. So since there's obvious motivation to prevent this from happening, what are some of the practices that I think we can adopt to prevent these security issues from happening? So there's something that I discovered recently. It's called security development lifecycle. We have software development lifecycle. So this was new to me. It was very interesting to come across. Within software development, I think it's related to agile. So where you're like collecting user requirements, then you meet with the client, and then you do a sprint, and then you after the sprint is done, you meet with the client, collect a new set of requirements, then you develop the final version of the software. So security professionals also have this workflow they call the security development lifecycle, and it involves a few steps. I'll try and link them below. But the first step is threat modeling. I think I've heard of threat modeling before, but I didn't know what it really entails. And threat modeling is basically a way of identifying potential security threats. So if you're running some server-side backend, I think what becomes obvious is, the main security threat is somebody hitting your server and finding some open ports that you haven't secured very well, and using them to to infiltrate your system. One that I've seen hackers try to exploit, at least on the services that I've been running, is if you have some runtime available on your service. So if you have either the Node.js runtime, the PHP runtime, I've not seen anybody try to target the JVM runtime. Or if you have what do they call it? This website development service. I've forgotten the name. WordPress. Yeah, WordPress. So if you have something like that running, so that becomes an attack surface for most hackers. So I think for software, the threat modeling phase is looking at the kind of services you're running, either on your server or whichever platform, and trying to identify which places the hacker might use as an attack surface. So if you have like a WordPress service running, you might look for ways to secure that. I think WordPress is very, very much common with that, because I think most sites on the web run on WordPress. I don't quote me on that. I don't have any data to back it up, but I believe a lot of sites on the web run on WordPress. And being that it's a service that's out there and it's available, and people can tell how you've engineered it, because basically you're basically forking some other software that has already been written by somebody else, and basically running it on your server. So somebody can use that as an attack surface. I don't know why PHP is targeted so much, because I see a lot of, let me call them script kiddies. They like looking for the PHP, some environment variable or something in the PHP runtime, and try to access the server that way. The other attack surface would be maybe MySQL, because they'll know likely you are running MySQL, and with this they usually prefer to do an XOR attack. This like I was saying, some of these are like new concepts to me. It's only that as a software developer I kind of have to research them, but you'll find that they're sending in as a normal legitimate endpoint that you've opened, maybe for a GET request or for loading the site. Somebody will use that to send a set of strings that when you consume it on your service and you don't validate the payload that you're being sent, when it goes to your database, instead of storing data, it actually executes a script. So the threat modeling phase kind of looks at those places where vulnerabilities might emerge. The other thing I found on the security development lifecycle is coding practices. And for this, I think the main thing is code review. We shall take code review as one of those inconvenient things that we have to deal with. But it's very, very critical, because if you're maintaining a master branch and you have multiple people trying to get code into that main branch that leads to production, especially if you have like a CI/CD thing established, then the code review phase is how you make sure that malicious code doesn't get to your eventual production environment. So that's why I think that's why it's part of the security development lifecycle. And there's just validating the code that's being sent and looking at output. You can do this with unit tests or integrated tests, where you have like a test environment, you have test containers, and you have like servers that you're using to evaluate how the software would behave if sent over to the production environment. The other thing would be, and I think most of us software developers know about this, exposing your credentials or security keys on your code repositories like GitHub. So you have to find ways to make sure that those security keys and credentials, maybe to your database or to whichever service you're running on the final production environment, are not exposed. And I think it becomes tricky, especially if you're doing CI/CD, because what you want is, you write code, you do a commit, and voila, it's available in production without having to interfere so much in between here, and that may tempt you to send the server-side compatible configs through GitHub, so that eventually when they get to production, it just runs. You send the database credentials, you send in the API keys, you send in everything that's needed, so that you don't have to modify the final build or the final build's configuration before it runs in production. So for me, what I try to do here is a bit old school. So I'll have scripts, usually bash scripts written on the server that, when the build comes in, it triggers those scripts, and those scripts are the ones that are responsible for injecting the particular credentials and security keys and any API keys that I need. So when it goes to GitHub, it's basically a blank slate. But when it hits the server, then you sprinkle in these other things that are required to get the software running. And then when you start out, you don't really notice that, and I think it's a mistake a lot of people make, and you find yourself pushing keys, very, very critical keys and credentials to a code repository that, if the vulnerability happens, maybe somebody in the organization loses their password, or somebody is able to get your GitHub account, then they're able to get some of these keys. People do this even for public keys. I think it's common, with especially guys who are running serverless, like Firebase. So you'll find somebody has enabled some services on their Firebase, and they've pushed this public code repository, and it contains their Firebase credentials or access to their Firebase resources that they've enabled. And I think it falls within that secure code practices. So the code practices also can become, if you don't have the proper code practices that ensure the security of your platform, those can become an attack surface for the platform that you eventually run. Under this, there's also static analysis, although I don't know how specifically that can be used for ensuring security per se, because within Android we have something called, I don't know if people still use it, but we have Lint, and it's basically a static analysis tool. It basically goes through your code and looks for common mistakes, as sometimes things that are as basic as grammatic errors. But there are ways you can use those static analysis tools to ensure that you don't have vulnerabilities being published in production. I'm guessing one of the cases is if you're able to get the static analysis tool to check for credentials and API keys within the code that's being merged or pushed to production. I think that's one way that you can be able to establish some resilience around that. So there are a few phases. I don't think I'll go through all of them. Maybe I'll just mention a few. Security training and awareness. So this falls under social engineering. So if the members of the organizations are not trained properly on security practices, they won't be aware of things like, if you get an email with a link telling you you've won 1 million shillings, don't click on it. Which I think that's how MGM was hacked. I think it was a social engineering attack where they infiltrated one of the employees, and they ended up just clicking on a link or something, and allowed that attack to happen. This one I think falls on the organization to be able to train the staff and tell them you need to follow these particular security practices. Yeah, so that's security development lifecycle. I'll share some of these resources after the space is done. I would like for this to be two-way. I don't think it's sustainable to assume that I'll be able to just talk for 2 hours. So if you're in the audience and you'd like to join in the discussion, maybe share a few tips on how you do your own security practices. I think I'll be very, very much open to that. For people who are joining now, so I had a speaker who was scheduled to join, but they are in a different time zone, and it seems they were either caught up or not able to join. But they had warned me in advance. They were like, the time that I've set, I think that's right now it's 8 p.m. They're in Pacific daytime, so I think that should be PDT. I don't know if Pacific time. So that should be 6 a.m. there. So it's slightly understandable, but I was hoping to have them on So I'll just maybe give a minute to see if anybody wants to. Oh yeah, I'm seeing a few requests here. So Habbes and Oguboye, Samuel, I've accepted you guys to speak. So so like I was saying, we had somebody in the computer security space who was supposed to join us for the space, but then I thought, even if they join, I think we should just proceed and see whether we can get a few inputs from the community, and from the people who are able to join the space. So, Habbes and Samuel, thank you so much, guys, for offering to speak. So, Habbes, maybe I'll give you a chance to introduce yourself. Maybe tell us what you do, and then I'll allow you to chip in and give us a few tips.
Hi.
All right,
Can you
thank
hear
you.
me? Oh, sorry.
Okay.
Can you hear me?
Yeah, I can hear you very well. Thank you so much.
Okay, yeah, I'm Habbes, but I'm also called Clement. Yeah, I'm a software engineer. I'm I'm not a security expert, but maybe I can just share my tips based from an application developer standpoint, like some of the things, the tips I've gathered from experience and the mistakes I've seen in code that maybe I can share around that, like based on just my experience as a developer. Okay, so I would say when we're learning like a development, there's a lot of like security principles that we learn, or that we from videos or tutorials or just from books or experience, like cross-site scripting and SQL injections, and salting and hashing passwords, or as you said, not putting secrets in tracking secrets in source control. And I think maybe a lot of people seem to be aware of this at some level, but there are also like some things that are low-hanging fruits that I've seen being done in a number of code bases, even by people who are like experienced programmers, and these may be security opportunities for security breaches, but they're also like very easy to fix. Like they're not like it's not like something complicated, like someone accessing memory through pointers. It's often like just principles that I think can help, is assuming that, let's say if you're building an application with a server, assuming like every input to that server is potentially evil and is potentially unsafe, and not trusting any input, even if it comes from your own website or from your own mobile app. So just, I think you have mentioned it about validation. So I think one of the most basic principle you can have to improve security is just validate every input, everything that comes into application from the outside. Just validate it, make sure it's of the correct type. If it's of, make sure it's of the correct like ranges, the value. Don't just assume that it's correct. And in like strongly typed or type safe languages, like for example, when you parse some JSON input, at least the parser, because those languages are like have runtime type safety, the parser can at least validate that the types are okay. Like for example, if you're expecting an int, you don't just get a string and that goes into the database. But with dynamic languages JavaScript, then you don't get that. You have to even validate the types at runtime. And one mistake I've seen is that people who use TypeScript, they assume that they have type safety, but they don't. They have compile time type analysis, but not runtime type safety. So maybe you can have like something from Express, you have request.body, and then in your application you kind of cast it to like let's say person. You have an interface or type person, and so that you want to put in the DB, or user, for example, and then you say rec.body is a user, and then you just pass that to your method, and maybe you manipulate it and store it in the DB, but you maybe have not validated that that's actually of the correct shape as a user. Maybe it has extra fields. Maybe it's not even an object. Maybe it's a string, or maybe you're expecting a string and you're getting an object, and every input. And if, validation on the server is like it's like indispensable. It's like a necessity. And then validation on the client is a convenience. It does not add security. It only improves the user experience. So one mistake is to assume that once you're validated on the client, that you can just pass that input directly to the server without validation. So I think that's also another thing I've seen, like not realizing that the client is running on the user's machine, and therefore the client, even if you're the one who wrote it, you cannot trust it. You cannot trust anything that comes from the client, whether it's like a web app or a mobile app. You should assume that that is from the user. You should not even assume that they're running the code that you wrote. You should assume that you don't know where that code is coming, whether that input is coming from. And one mistake I've seen is that people may not take into consideration that the app is running on the user side machine, and therefore the user has access to the code that is running on their machine. Like you cannot hide anything from the user if it's in the client. So for example, if it's JavaScript, the JavaScript code is running on the user's browser, so everything is there. So you should not put anything secret like API keys or anything or passwords in the client. And this also goes like for desktop applications or for mobile applications. And even if you send binary code is still code. It's not like for the machine to execute that binary code, it has to interpret the instructions. So all the instructions are there on the user, and if the machine can do it, you can assume that the user can do it, because these things are reversible, like they can be reverse engineered. So don't assume that you can hide secrets from the user because you use like obfuscation, like binary that has been obfuscated, and assume that is eventually someone who's determined is going to reverse engineer and find the secret. So if you have like some secret thing that you want to access from the client, you should move that code to the server and then make an API call, and then the server will authenticate that call and then decide whether or not to pass that value to the user. Like this, just a concrete example that I saw. Someone was working on a feature to send data to S3, like Amazon S3. It could be anything. And so because they did not want to send the file, they want to upload it directly from the client to S3 to save the step of going through the server and then sending the file to the server, and then the server sends to the S3, which would take more time and be more expensive in terms of resources. So what they do, they initialize like the client from the server, the API client from the I think it was a mobile app, and then they make that upload request directly from the client. But in that case, like the client stores the API key, which is I think this was API key and API secret, which is like a security vulnerability. So in that case, the right thing would have been S3 and other APIs that offer a service where you store the API key, the secrets on this are only available to the server, and then the client will call the server, and then the server will tell S3 generate a unique secure URL that is only valid for this particular file and only valid for this amount of time, and then send that URL to the client, and then using that URL, the client can send that file directly to S3. And this URL, even if it was compromised on the client, it only has access to that single file for a specific duration of time, so the risk is limited. And another also problem I see which is related is build tools like I think React Native or Webpack. They also kind of allow you to store like environment variables, and people are used to the idea that it's okay to store secrets in environment variables because they're not accessible they're not in code, and they'll be in memory on the server. So the code, so it's kind of like safer than putting it on the code. So people also put like environment variables on client side build tools like Webpack or React Native. But the thing is, these are not environment variables in the same way as the server. Like when the build tool compiles or generates the package for your app, these environment variables in quotes are actually going to be part of the code or the artifact that is on the client. So it's in the case of JavaScript apps, this is going to be whatever you put like in the environment env variables are going to be part of the actual bundle code that is in JavaScript. So it's going to be available as plain text in the code, and on the mobile app, it's also going to be available either in the binary or some configuration. So in the case, it's kind of like a false sense of security. So, but you're actually exposing secrets. So these are things that I've actually seen from people who experience. So they are low-hanging fruits in the sense that once you're aware of them, they're easy to fix. But what I've learned is that they're not obvious, and they are mistakes that actually I've seen in many code bases. Yeah, another thing that maybe is less that I've not really seen a lot of concerns about, which personally I still find as a concern, is sometimes like we install open source libraries, but these things run arbitrary code that we don't audit and we don't look at, and we kind of install them based on trust. And these libraries, once they run as part of your program, they're in the same process as your app, and so they have access to the same memory and the same permissions that your process has. So technically, it's possible like for the library to read like your environment variables and send that to some server behind the scene without you noticing. So we usually have like a firewall to kind of restrict access into the server, but I don't think I've seen a lot of people maybe think about maybe we should also restrict access outside of the server so that our server can only make requests to domains that we have whitelisted. For example, if we have certain APIs that we have integrated with, maybe make sure that only those APIs requests are made to those APIs and not to some like third-party endpoint that some malicious library that we accidentally installed is trying to communicate with. So the other thing is also just reducing making sure if you're like using third-party services that use the least amount of permissions needed to access those services. You don't like use the admin credentials for everything, or you don't necessarily store the API keys in the environment variables. Like some services, like for example, I know in Azure, they provide a feature called managed identities, which kind of allow you to limit the exposure of these credentials instead of like storing actual API keys that have like all these powers. And if some malicious activity has access to your memory space, then you can get all this power. And sometimes it could just be like a programming mistake. Maybe this API key is stored as a property in an API client, and then your code maybe is just has console logged the client, for example, and maybe that console log prints out the properties of that object. And so that properties might include now the secrets. So maybe now your service is actually logging these secrets, and you don't have tools to kind of filter out the logs to prevent that sensitive information is not logged. And maybe you're storing these logs in a file or in a database, and so you might just have like logs are exposing secrets, and we may not be aware unless you scrutinize the logs. So I don't know. I think I've spoken in many directions without any structure. So I think I'll just pause for there and leave it to someone else.
Thank you so much. I think that was really, really informative, and thank you for offering that really important information. I think you've covered some really key points that if taken.
Yeah, returning the
Mm.
mic to the host.
Oh yeah, let me know. Let me know if you can hear me.
I don't know if you can still hear me.
Yeah, I can hear you. Samuel, can you hear me?
Yes, I can hear you. Can you hear me now?
Yeah, I can hear you very.
All
Yeah, I
right,
can
all
hear you.
right. Seriously, Habbes has said it all. Has said it all. I just want to add that as okay. Firstly, I'm Samuel Boye from Nigeria. I'm a software developer. I'm also into DevOps. So the most important thing, Abis has said it all. The most important thing as developer is that as software engineer is that we should understand how this how cyber security works and everything about it. Personally, I've had experience when I started developing. There was a particular time I made a script and I had to use my Google app password. And just by mistake, I included the Google app password in my GitHub repository. Just after some time, I just saw that there was a login into my Gmail account and a lot of things going on. So when we understand how this thing works, we'll be able to have a better understanding in securing our softwares. And also, when we understand the other things about cybersecurity, maybe like SQL injection, brute force attack, we'll be able to create an environment for our users to be able to safeguard themselves, because it's not even just about us, it is also about customers' trust. Maybe a company that get breached and customer data get breached, and password, email address gets flies around, the trust for that software is going to reduce, is going to come down. So it's not just about what we have at heart or maybe the data we are trying to protect. We're also protecting the integrity and also preserving the trust of our users, of our clients. So that's one thing that we must understand. So when we understand how they work, because even personally, it was when I understood how brute force attack works. That was when I was able to have a proper understanding of how everything is all about. So with that understanding of brute force attack, I was able to my subsequent production, I was able to make effects and do what is supposed to be done, and make all the necessary adjustments, all the necessary precautions, so that no matter how the brute force attack comes, a client will still be saved. So just by putting password, user password, you need to use a minimum of 16 digit password. The first character needs to be there needs to be an uppercase, there needs to be an other characters in it. So all these things is to protect our customers so that their password will not be easily guessed and their username will not be easily guessed. Another thing I want to say is that as software engineers, we need to get updated on the current trend, because as technology is getting advanced, also technology in the hands of criminals getting advanced every now and then. Before this time, brute force attack, for you to run a brute force attack on a particular account, it will take a whole lot of time, because you have to be testing it over and over. But nowadays, we have some sophisticated softwares that can run brute force attack in. You can run 40 million guesses in 5 minutes. So 40 million trials in 5 minutes on your account. And another thing is, as software engineers, software developers, for example, we have rate limiting. It depends on how you want to build your app, putting all these functionalities in place, rate limiting, that okay, if this number of requests comes to this if number of requests comes to this particular endpoint in this particular minute, the IP should be blocked. Maybe, for example, an endpoint is supposed to, at maximum, supposed to get maybe like 10 requests in a minute or 20 requests in a minute, and you're getting surge of, you know, 100 requests, 200 requests, 500 requests in a minute on a particular endpoint. I, that's the point of consideration, that okay, since this is this, I'm going to put a kind of rate limiting functionality that can limit the rate at which request is being sent to this particular endpoint. So by the time we put all these things in place, and also all these things summarized as pen testing. Although we have some cybersecurity agents that are very professional in this. Also, personally, we can also do some preliminary pen testing on our softwares. You can run SQL your program, even development, and see if it's going to work. And also, for example, SQL injection, there are a lot of techniques in which you can actually use to mitigate, reduce, ameliorate the effect, like using object relational mapping, by using pagination, and a whole lot of other techniques that will reduce the influence, the injection of malicious code into our program. So when we put all this at art, we protect our own personal data, we protect the data of our application, and we also protect the data of our user. Another thing that I think this should be the last one I'm going to say is that do not trust anyone. Do not just assume that all your users have bad intention. Assume that all your users have bad intention. So when you assume that all your users have bad intention, the way you will structure your program, you're going to be 100% security conscious. That okay, the first user that I'm going to have might be capable of hacking through this account in this way, in this way, in this way. So when we put that at that, we do not just trust anyone. We can only trust ourselves. We cannot trust the other persons. So they might have bad intention. When we put all these things in place and getting updated on the current trend of security, current trend of of inadequacy, because a lot of high companies, a lot of multi-million companies have in past been a victim of these vulnerabilities. So there's nobody that is no software is above the possibility of being vulnerable. So, but being constantly aware about all this, monitoring can also go a long way. When you set up watchdogs like Datadogs and all those kind of softwares to monitor the inflow of requests. You can monitor the inflow of requests. Maybe by the time, and all these things are automated. So when you monitor the inflow of requests, there are some normal requests that you get, but when you get abnormal, you get to work to try to mitigate the effect even before any user knows what is going on. So thank you very much. I think I'm going to stop there. Uh, thank you. Thanks for the opportunity.
Thank you so much. Thank you so much, Samuel. I think those are some really good points. Together with Habbes, I think you guys have provided some really good tips, and I have to thank you for chipping in and giving us this really good information. So before I proceed, I want to make sure that you guys can hear me. So just confirm with me, Samuel, if you can hear me.
Yeah, we can hear you.
Okay, wonderful. Yeah, so maybe I can recap some of the things you and Habbes have highlighted. So I think one of the things that was highlighted was that you cannot trust your client applications. So even if you programmed them, maybe you have like a mobile application or a web application that's communicating with your backend service, or vice versa, you cannot trust the source of the traffic. And I think this comes from cases such as man-in-the-middle attacks, where somebody intercepts your network traffic and interferes with the packets or interferes with the payload that you're sending back and forth. So by the time it arrives on the other side, it looks genuine, but in fact, it has been interfered with. And I think some of the remedies you guys have suggested, and I think they are solid. Applicable things is one, to validate requests. When you're first writing the service, you don't really think too much about this. You just write the endpoint, and if it works, it's fine. You have some basic auth for the endpoint, and maybe you added one security header. So looking at the payload and validating it, I think is a very good point that you guys have brought up. And that reminds me of a common attack, cross-site request forgery, CSRF. I think that's one of common security attacks that are listed. And this is where somebody goes to some website, and because they had already visited a site and submitted a form to that endpoint, maybe they were checking their account balance or just logged into their bank information, then another site can send a similar payload to that backend service masquerading as this user because it's running on the same browser. And with that, that the server might process that request as if it's coming from the client. Turns out it's maybe an automated script that's running on the client's browser, or this guy is submitting a form that behind the scenes there's some hidden fields that are actually triggering some maybe account withdrawal, some other service that would maybe go to their bank or some other backend service. So that's cross-site request forgery. I think that's the technical term for it. Otherwise, I think the main point is don't trust the payloads coming to your backend. You have to validate all requests. Then I think somebody also mentioned using a credentials manager. I think this was mentioned by Habbes, using a credentials manager for your security. And I think this comes from secrecy. So you try and make sure that even within your service, within your servers, or within your code repositories, those credentials are not exposed in any way. So you try and use a credentials manager. I've seen GitHub make some steps towards this. So they recently emphasized enabling two-factor auth, and with that you can either use the old school, the usual OTP SMS verification, where when you log in, sends in a one-time OTP code, then one-time use password, and then you're able to log in with that. The other one that they're suggesting is using some other credentials managers, like I think there's one I'm using called, let me just check, Authy. And these like applications that are able to generate codes, and you're able to like authenticate with those codes when next time you log into the service. So Authy kind of acts as an intermediary, a sort of credentials manager for maybe your GitHub account or whichever service you're using. So there are various ways, I think, that you can I use to make sure that the credentials of the user are protected. Even if some client tries to log in with the similar credentials, you have some other additional ways to validate that this is actually the user who is trying to log in. And I think this comes from your point, Samuel, where you talked about don't trust anyone. Don't even trust your client applications. Even when they present you correct credentials, you should have some other way of validating, at least validating either the request or validating the contents of the request that are being sent to the service. And the other one that Habbes mentioned is make sure that you don't log your secrets. So you might be doing this during debugging, or maybe in Spring we have some Spring Boot, Spring Framework, we have something called an aspect-oriented programming style, where you can write one function and you tell it for every function that executes with this signature, please do this. And one common thing that we use that aspect-oriented programming for is for logging. So you can say for any time this particular endpoint is called, log this, send this to our logs. So with that, you might end up leaking some things because maybe later on you change the function to handle some sensitive information, and your aspect-oriented programming code will pick up that function and log the operations that are happening within it. Probably you forgot that you had that kind of thing running, and somebody can use that to intercept your traffic and be able to tell how you're processing your payload, or leak some things that they can use to later on crack your security, the security that you establish for the service. Maybe another thing that I found to be very important is staying updated with the current trends. And this reminded me of something called SNDL. I think, is it SNDL? Basically is a method where, and this is used by governments and organizations that can afford to do it. So what they do is they collect encrypted data and encrypted traffic, and the plan is they collect that data. They cannot encrypt it now using the existing computing because of most of these algorithms. You try to crack them if it's secure enough. If you're using something like AES, if it's secure enough, it might take you infinity to decrypt the contents. So what they do is they store that encrypted data with the plan of later on, when quantum computing reaches the levels that it should reach, then they'll be able to use quantum computing to decrypt this data, because the nature of quantum computing is different from the standard mode that we use for encrypting the traffic. So the idea is, with quantum computing, you can actually use it to crack existing encryption standards. So that's an interesting trend that's going on. And in the same point, there's a service called Signal. I think we all know Signal, the only real end-to-end encrypted communications platform on the internet, I think. WhatsApp claims to have implemented the Signal protocol for end-to-end encryption. But of course, we know the company behind it, Meta, kind of relies on accessing some of this data to sell ads and stuff. So it's questionable whether they are really using the whole Signal protocol, because Signal protocol promises that once the message leaves your device and goes to the destination, nobody can be able to intercept it. And the protocol is significantly advanced enough to prevent any form of interception. So there's something interesting that it's actually a non-governmental organization, Signal. There's something they discovered recently called quantum resistance within Signal protocol. So basically, they developed an algorithm, an encryption algorithm that, if they are right, should beat quantum level type of decryption. So if they secure their data with this new protocol, when quantum computers become mainstream, this plan of governments and other organizations collecting this data to decrypt later, if it was encrypted with their protocol, then that data will be secure. It will be able to be decrypted. I'll link the blog post that they did for the same, but I think that's one major trend within computer security that's happening currently. And companies like IBM have made advancements in quantum computing. Also, Google kind of seems to have made some really major steps in that. So I think this is something that's critical at the moment. So that's just on the kind of trends that we are seeing. There's something that was mentioned regarding hashing and rainbow attacks. It's something we had discussed with Stanley. He's on the space. Thank you, Stanley, for joining. So we're discussing about hashing passwords, and the idea is, if you hash a password, maybe with SHA-256 or any hash function, that password the hash cannot be reversed, and it's actually true that the case is you cannot reverse a hash, but with the rainbow attack you can guess, because the way hash functions work is, once you do the hash, if you do a hash for maybe password 123, the resulting string, or the resulting encoded string, will always be similar for the same output. for the same input. So if you do password 123 again, it will produce the same output on the other side after hashing. So if somebody does a rainbow attack, then they can just check whether the resulting hash is the same. Then they can tell that the password was password 123. I think that falls under rainbow attack. I think Samuel, you mentioned this under brute force. So I think that's something interesting to consider. Oh yeah, and I think this is one of the most important points that have been mentioned. Always assume that attackers are coming, and don't trust anyone. Again, so when you're building your APIs or you're building your services, make sure that you establish security to the best of your ability. Just assume that somebody is going to try to crack your system, and I think it's common on the internet, even if either script kiddies, some rich kid in the UK or some Russian hackers, they're just playing around maybe in the afternoon. They're like, oh, let me see if I can crack this particular server. Your IP just happens to be the one on the top of the list amongst some of the services they are trying to like play around that week, and you end up just being a victim like that. So it's always important to imagine, just have the mindset of somebody's going to try and break my service. And lastly, before I hand over the mic, the other one is monitoring. I think this is a very important point. Establishing some monitoring practices on the server, whether with the Datadog. Within the ecosystem I work in, we have something like within Spring Boot, we have a service that allows you to do some monitoring. It's called Spring Actuator. So you can establish that and be able to see what's happening on your server. So that is not just a black box that you deployed. You can actually see, oh, okay, these are the kind of events that are happening. These are the kind of requests I'm getting, and this is the kind of payload I'm processing. So that if there's even an attempt, you're able to do that. I think even within Nginx, Nginx logs every request that comes in, and if you're running it in a Linux environment, you can always get those logs and be able to see which kind of requests are coming in. And if there's a script kiddie or somebody or a serious attacker, trying to break through your system, you can be able to see it early and maybe start to either deal with the services that might be exposed, or try to add in more security. There's something that was mentioned on the replies by Dr. Natkes. I think Dr. Natkes mentioned that and I'll read this. What he says, we have spoke a lot about the application layer. What about securing security from the network? This can be by configuring firewalls and pen testing. So, I mean, you have to also think about the network and the hardware and the OS layer. So, configuring a firewall. I got this tip from Stanley through one of our discussions on the TL. If you have failed to ban, it's a very good service. So you run it. If somebody is trying to do some brute force attack on your service, you're able to. The fail to ban is able to detect that and lock them out. Of course, pen testing, which is controversial. I wish we had a discussion with a security professional. I was hoping we will be able to look into pen testing and what kind of process should be followed in order to do pen testing. Somebody doesn't just disrupt your service and they're like, oh, I was doing pen testing, when you maybe suffered losses and stuff like that. So I think those are the main points. I'd like the discussion to continue. So Elizabeth, thank you so much for offering to speak. I'm sorry I took a while to do a summary for the other guys, but I'm very, very much interested in what you do and just get a few tips and ideas from you on computer security. Thank you so much. You can go ahead, Elizabeth. Elizabeth, if you can hear me, you can go ahead and speak. Thank you. Elizabeth? Okay, as we wait for Elizabeth to come on, Elizabeth, anytime you're ready, just let me know so that I allow you to speak. You can just unmute. I think maybe you're speaking and you're on mute. Yeah, just you can unmute and we can hear some ideas and some tips and tricks from you. So as we wait for her to speak, I think it's important to know what already exists there, so that even as we are trying to handle the security of our systems, at least you go through the basics. So that you're not attacked for something that's very very commonly known and something that you would have already probably dealt with. So I think Habbes mentioned this where he talked about SQL injection as one of the common attacks. So SQL injection has been I think when I first got introduced to computer security, I think that's one of the common ones that I heard about. The other one I learned about was denial of service attacks, but SQL injection is very common. Back in the day, PHP used to be very vulnerable to it. I think because of the way the forms were programmed. I haven't done much PHP, so I can't tell this for sure. But this is where somebody passes in some malicious user input that instead of being the common the query that you expected to execute on your backend, it ends up manipulating your database. So it could fetch data from your database, or it could end up corrupting your database all the same. I think that's one of the most common attacks on the internet. I don't know if things have changed, but that's one of the common attacks, mainly because script kiddies are also able to find free and easy to use tools that allow them to do SQL injection on almost any service. But of course, security has advanced beyond this a bit, and I think even if you're running the most basic security, you'll likely be safe from this, especially if you're doing input validation for user input. If you receive a payload, you're doing validation for that. Of course, I mentioned denial of service attacks. I think we saw this with the recent quote-unquote hack on Safaricom and some of the essential services in the country here in Kenya. Which apparently resulted from some other nation-backed hacker group. I don't have the facts for that, but anyway, that could be an example of a denial of service attack. So this is where the attacker overwhelms your service with a ton of traffic that you're not able to process in time, and it ends up blocking legitimate requests from your customers and the actual clients that you expect to access your service. Then of course there is ransomware attack. I talked about the MGM case where the hackers came in and they're like, oh, give us this amount of $1 million and we'll be able to allow your service to continue running. Otherwise, you won't be able to access your service anymore. Cross-site scripting. I wish I had somebody from the web, from web development. I think they would be able to explain XSS attacks a bit more. But I believe this is where somebody tries to execute a script from maybe some other client to your backend. And by this, they inject some malicious scripts that execute on your backend. And I think for web developers, if you're using some client-based libraries, web developers will hate me for this, but the latest, most modern client library that I know about is jQuery. And if you're doing jQuery and you're doing a XHTTP request, I think by default, cross-site requests are disabled. And I believe it is to prevent this particular attack, to prevent cross-site scripting. If anybody has any additional points on that, I think they can share. But I believe that's the case. I don't do web development that much, so my knowledge is kind of limited on that. Of course, I touched on social engineering. That's one of other common attacks. Insider threats, we talk about educating your within the organization, educating the people so that they don't become the point of attack. Yeah, and I think I'll hand it over to Habbes to add in a few points, and then we can discuss common vulnerabilities, and then I think we can see where that takes us. Otherwise, we might end up ending the space if we don't have any additional input. But I think that's one other area that we might have left. So, Habbes, the mic is yours. Oh, and Elizabeth, whenever you are ready, just let us know, and I'll allow you to speak.
Hi. Just wanted to add some context to the cross-site scripting and how it used to work, or how it still works. It's just that now there are more. More libraries protected by default. So the idea is, as you said, like injecting code. Injecting code on another user's client. So for an example, is let's say you are a user and maybe you are creating your profile, and as part of your name, you enter like some HTML tags, like let's say P or B, blah blah blah, and then now that stores in the database as a string. And now let's say when the server is generating the page, let's say now another user has a list of friends, and you are one of the friends of that user. And so maybe this endpoint that shows the list of friends of that other user just fetches the people from the database who are friends and just displays their name. So if the names are just displayed, if the server just writes what is in the DB directly in the HTML that sends to the browser, then it will send the HTML tag that the browser will pass as HTML and render as HTML. So if it was maybe a B tag, maybe you'll see that the text is bold. But if it was something like a script tag, that's a JavaScript, then now you can inject some code in that JavaScript, and the browser now seeing a script tag will try to execute that JavaScript. So that's kind of like how you would do cross-site scripting. So the way to avoid that is now, instead of just sending like instead of the server just sending the raw strings as is to the browser, it will try to escape the HTML. So instead of like a tag, instead of like the less than sign, it will replace that with, like, let's say ampersand LT semicolon. And so the browser will see that this is the escaped representation of an ampersand, of a less than sign, and it will display the less than sign instead of treating that as like a HTML tag. And so now modern libraries like React or Vue.js, or even templating languages, server-side templating languages, will do this escaping by default for you, so you won't have to worry about it. But in the past, you had to do it manually. I think PHP had this function called HTML special escape or something. I don't remember, that you'd have to call manually. Nowadays, most libraries do it by default, but there are some cases where you would want to actually render raw HTML as the developer, and in such cases, these libraries give you like an escape hatch. Like I think React has a function called dangerously render HTML, which now disables escaping. So that is if you really know that what you're doing, and you know that you want to, you know that this is safe code and stuff like that. You've maybe done your own validation and you know what you're doing. Maybe you're doing like some HTML editor where you actually want to render to pass HTML to the rendering pipeline as opposed to strings. So that's, maybe not nutshell how cross-site scripting worked and how it's prevented.
Oh, thank you so much. Thank you so much. I think it will still take me a while to process that, because I don't program on the web client as much. No impact at all. Yeah, that will take a bit to understand. But I'm sure guys who have done some web development here will probably have understood that. Yeah, I think I'll try and check out some more material on it, and maybe that can help me understand it a bit better. Because for me, when I look at things, I'm mostly looking at them from the server backend perspective. Mostly in terms of what I'm receiving as requests to my backend. But I appreciate there's a lot that happens on the browser, even with the CSRF, cross-site request forgery type of attack. It's mostly something that originates on the server. So yeah, Samuel, let's hear from you.
All right, thank you, Abby. Thank you too. Concerning the you were saying that you know about server, attacks come from both front end and back end. Attacks, it comes from both client side and the server side. Something I want to say about SQL injection is that some people still, for example, I'm a Python developer, and I use Flask, Django, and all that. There's ORM, object relational mapping. Why some just use bare SQL queries in the bare SQL queries in the in the program? That using BSQL query in the program is more vulnerable. Is more susceptible to SQL injections. Um, so using object relational mapping, object relational mapping is like a bridging gap between creating an object in Python and also the database. So it's converting object to the table, converting table, bringing table back to object, and it has his own dialect. It has his own dialect. It's not the normal SQL dialect that creates select star from table where user ID is this. So using bare SQL query in program, we make a window open for attack because SQL injection, the attacker might just put in quotes to just how SQL injection works. Okay, let me just give you a brief um part of how SQL injection works for those people that don't know how SQL injection works. SQL injection, for example, when we have select star from, maybe it's like table ID where user ID equal to the user ID that you collected from the client, or maybe like a password from the user. So instead of user putting the password, the user will put in something to complete the string, and also a true boolean, or one is equal to one, then end the statement, then put a hyphen that denotes comment in SQL. So that comment in SQL, it will exclude every other thing. So it will just bring, instead of bringing information about that user only, to bring out everything about the user and all other things, all other methods in SQL injection that is used to get all other information. But using object relational mapping makes it harder. It makes it harder for the attackers to be able to inject malicious code inside the program. And another thing is like input validation that you say. Input validation can be done on the client side, can also be done on the server side. For example, those times when I was just learning about SQL injection, there was a particular site that I just went to. Okay, although I don't have a bad intention for this website, but let me just try one of the SQL injection on this. I will just see what is going to happen. So when I just put apostrophe inside the username, the browser just refreshed that apostrophe is not allowed. So that's the form of validation. Apostrophe equal to symbol, and all those kind of things that might be used for SQL injection is not allowed in the feed. So when it's not allowed, then the attack the damage, the attack will be minimum. And also, for example, how SQL injection also works is that instead of we have username and password, instead of putting username username that has something at something.com, and the person starts putting one equal or all these kind of things, immediately the client side validation, this is not a valid email. this is not a valid email. So once it's not a valid email, that means it can't put through. So another form of attack is man in the middle. You know, the from the front end to the back end, there is exchange of information, and by HTTPS protocols, and know that the packet of data is being sent over. So when you, maybe the hosting that you use, or the kind of configuration that you use on your server is not well protected, a sniffer can actually see what is going on. And although what is going on, the exchange of data cannot be covered, but it can be secured in such a way that even if an hacker sees packet of data going on and on, we will not be able to see what is actually inside. So we'll not be able to see what is actually inside. That's another way in which attackers attack. Another way is session hijacking, stealing user session information. You know, most times at the back end we keep user session information to keep a lot of things, maybe to keep the browser details or the user details or some kind of thing. So session can be used to gain unauthorized access. Because, for example, if I have a website and I say, okay, this session will be valid for this particular time, and unfortunately the session is still valid but gets into the hand of the attacker might use the session that is alive to gain entrance into the attack. At the other time, I mentioned brute force attack, like repeatedly trying all possible password combinations. There are a lot of websites that if I just enter it, maybe I put 1234, you see, 1234 is not allowed, or repeating numbers are not allowed. Maybe I put 112244, repeating numbers are not allowed. So all those kind of validations, we make it we make it possible. We ensure that users use passwords that are not easily guessed, so brute force attack will not be able to work. Another thing is education, educating the users. Maybe you have a software as a service, you have any software that you're running is already out. Education, educating your users about phishing links, because actually it's possible that um a website can be built closely resemble your software, your website, and when the users click through submit the details, entrance is gained into it. So phishing link can also deceptive tactics used by these attackers to get sensitive information and password. Another way is using 2FA authenticator. Providing 2FA authenticator, it means that we are not just relying on email address and password, but we are relying on another step of authentication to make sure that, okay, even if attacker has access to your account, the attacker, we need additional information to be able to have another a further access to the account. About the password hashing, um password there are a lot of password hashing algorithms that cannot be easily guessed and cannot be easily decrypted. For example, in Flask in Python, we use sometimes we use BCrypt and all that. So the hash password is being stored in database. So even if, although we should secure the database, but peradventure the attacker gets entrance into the database, the attacker will only see the hash password. And when the algorithm when the algorithm is so strong, the time taken to decrypt it is going to be longer. So these are the little things that I just want to add to it. Thank you.
Thank you so much, Samuel. Those are not little things; they are very important. So, thank you so much. I'm glad you were able to expound a lot on session hijacking, use of brute force, and phishing attacks and a bit on password hashing. So I think you mentioned some really important points. When doing APIs for client applications, and you guys can give me a few tips on this. My strategy is usual to disable sessions for client applications. That if I receive the payload and process it and tell the client that the request was received, that session is terminated. In fact, a session is not created; just the request response is completed. I think for the web, it's more challenging because you have to provide. Some session mechanism for clients, either for things like Remember Me or be able to allow them to access the service within a particular period. I think just generally the way the things work on the browser, you have to have session management. Otherwise, for client application, I think if you're doing just a REST API or a GraphQL API and your client is likely not the web, then I think one strategy would be to disable sessions completely. Maybe one of you will be able to comment on this and see whether that's a good security practice or strategy for maybe protecting the service against session hijacking. I'm glad you mentioned BCrypt and other password in comparison with other password hashing mechanisms like SHA-256. I think SHA-1 was discontinued and is no longer advised for use together with is it DHS or one of you will mention this. I've forgotten the name. I think SHA-1 and one other hashing algorithm were disabled as a strategy because hackers found their way into easily being able to decrypt passwords that were encoded using or rather were hashed using that hashing algorithm. Maybe one thing, although I don't know if we're able to dive a lot into this, but if we could be able to discuss public infrastructure, maybe on this space or on the next one, we'll be able to discuss this a bit. So the protocol that I mentioned earlier, Signal Protocol, runs on a PKI infrastructure where you have like a public-private key kind of established, and you use that to encrypt the message. Signal is a messaging service, and I think a lot of communication and messaging services use this, but I don't think it has to be limited to that. I think you can use it to secure even normal APIs, even if they're not like a messaging APIs. And if you establish like a public infrastructure, you can be able to maybe encrypt your traffic, gets on the server is able to have like its own public key, or the public key shared between the server and the client, and then there's a private key that's used to like decrypt the traffic or the data that's sent over the request. I've not seen anybody use it necessarily for like REST APIs, although services, security strategies such as JSON Web Token (JWT) kind of use that kind of mechanism, public infrastructure. But it's something interesting that I think if we get time, we should be able to have an interesting discussion about. So in the meantime, I think I'll give this chance to Collins. Collins, maybe you can introduce yourself, tell us what you do, and maybe give us a few tips and contribute to this interesting discussion that we're having regarding computer security. Collins, you can proceed.
Oh, thanks, Samuel. I don't know if you guys can hear me.
Yeah, I can hear you very, very well.
Okay. So I'm a software engineer. I'm a freelancer at the moment, but I've built a few products here and there. And I stumbled upon this conversation by chance today. And so I thought I'd listen in, and I really liked it. It's very technical, and I've enjoyed it. And I thought maybe I'd add one or two things from my professional experience. In fact, I just want to add one thing, which is most of the time, security comes from, I'll say, common sense. And as a developer, I'll say like you ought to think about your product, but also you have to think about the users and the people who are interacting with you. there's a very, very good case of a company in Africa, let me use Africa, that has raised a lot of money that was hacked in one of the most interesting ways. And I'll just go through that story. And part of this is also you have to think about your competitors, because some of the things that they Google about you would go beyond what a normal person would Google. So for example, let's say today I'm competing with you, then I'll go online and Google and say like, okay, my competitors' customers, who are they? You know, something really random, and you don't know what will come up on Google. So in this particular company, someone Googled about them, like in depth, and they had, I'll say, their version of Jira or Trello, which was self-hosted. But now the problem is they didn't have it around a VPN, so it was exposed on the public internet, and so you could see the things that they were discussing internally. So now these are not the developers only; these are customer support representatives. These are, I'll say, the product managers in the company, the different people who do different roles that are even non-technical. So one of the things that they were discussing was, I think, a bunch of customers had issues. So they were like, okay, the following customers have issues, and these are their phone numbers. So already you have from that a piece of information about this company. And then on their mobile app, this was, they didn't have, I'll say, a front-facing web application, so they were mostly web. All you needed to log into the application was a mobile phone number. So now imagine they had maybe 5K customers, and there are hundreds of millions of phone numbers across Africa. So it's very hard for you to get those 2K numbers for you to log in. But now with this board, you have about maybe 10 or 20 customers. So now you can you can download their mobile app and you can log in. And now you'd be logging in as a customer, right? But now it goes beyond that. So the attacker, I think, now downloaded the mobile app, the APK, and ran it on an emulator. And then what they did was they put a proxy in between the application on the emulator and the backend. And so what that happens, what that means is you can be able to see the request that this particular application is like reaching. You can be able to see the request and kind of like download all of it, and you can see the tokens, the authentication tokens. I don't know what kind of tokens they're using, but you could download that token, and you could be able to see all the endpoints. And now the final thing that the attacker did now was to try that endpoint with now the different customers, right, and the different endpoints. And so what that ended up like the last point was this company had been careless. They didn't do, I'll say, they didn't validate, or they didn't check who owns the resource, or rather if like a user is supposed to view a certain resource. So for example, let me use this example. As a customer, you can see your orders, but then you're not supposed to see the orders for everyone else. But then they didn't do that check at the back end. And so all of a sudden, with those set of steps, this company lost all of its data. It was exposed into the internet, and the attackers were able to download all these things. So I think as a developer, I think that's one thing you need to look into. Like, are you thinking about your system end to end? Are you thinking about these little, are you dotting your I's and J's, right? Like, are you looking into these small things that are very critical? Yeah, so that's all I wanted to share. Like, just use common sense, be thorough, like look at other things beyond your application that can expose you. Yeah, and that's all. Thank you, Samuel, and thanks for this great conversation.
Thank you so much, Collins. I think first of all, thank you for offering to at least give us some of those very important tips. And I have to agree with you. Sometimes it boils down to common sense. I think the challenge that professionals and especially software developers face, even if they have like a security professional in the team, or they're trying to ensure some of these things, is when the management kind of puts the business needs ahead, and in some cases forget to emphasize, taking a step back and, considering, okay, we want to build the best service possible, but have we taken care of securing, basic things like our email service, just like you mentioned, common sense things that normally would be considered at the beginning before you even think about these advanced things of maybe establishing a public a PKI infrastructure, or implementing this protocol, or adding a firewall and doing some of these things. At least some of those basic common sense things should be covered. I think the challenge is usually balancing business needs and ensuring that whatever you're building has longevity by the aspect of you taking care of those nitty-gritty security practices that should be in the organization. But I agree with you, and I thank you so much for those tips. I think I know the organization you're referring to that got that strange attack. But I think in the interest of time, we will not dive too much into it. But thank you so much for your input. So now I think I'll give it to Brian. Brian, maybe you can tell us a bit about what you do and chip into the discussion. And before I hand it over to Brian, Habbes, I hope I'm pronouncing your name correctly, Habbes. But Habbes corrected me on that hashing algorithm that I forgot about. So they discontinued SHA-1 and MD5. Yeah, the name is MD5. I had forgotten that. I knew there was like a D somewhere there, but yeah. So it's encouraged that you don't use those to encrypt or hash your passwords. I saw somebody in the TL mention that encryption and hashing, and hashing is not encryption. People should not confuse those two things. I think that was another interesting discussion. And I think this goes into another important point of knowing common vulnerabilities and just making sure that at least you're making an effort to secure your services against those very much known vulnerabilities, such as SQL injection, not having a firewall, having your SSH endpoint not accept passwords, maybe using establishing a PKI infrastructure. If you're not using a port on your server, it shouldn't be open. Some of those common sense things, like you mentioned, Collins, I think as engineers, there are things that we should take care of before they bring the cybersecurity guy to now go into the network interface and implement sophisticated things. I think those are things that we can take care of before then. So Brian, the floor is yours. You can proceed.
Hello everyone. I'm Brian. I run a dev shop. It's essentially a software consulting outfit. But I essentially write code, like I think most of us here. And I have to say, I thought his name was Habbes, not Habbes. And then, the reason why I thought of Habbes was it's the three-headed dog. There's a protocol, a network protocol. It's called Kerberos. I remember when you're learning about security. So anyway, I thought that was an interesting segue. There's something I noticed, and especially if you're doing payments. I don't know if anyone here is doing payments. We do payments once in a while. It's sometimes your payment provider, it could be a bank, it could be Safaricom, it could whatever it is. There's that payload that they send to confirm that a payment has been made. If you're not very careful, for instance, if you don't whitelist, because I think Safaricom keeps on sending the IP addresses that you're supposed to whitelist. If you don't do that, a rogue entity can send malicious payloads, which are almost the same as what can I say, the payment providers offer. And then, somebody can say that they have paid for something when they have not paid. This is something I'm not going to say I've done, but maybe I've done for experimental purposes, and I've seen the possibilities. And then the other thing I would say, it's not so much to do with the software per se, but I think if you if you can have regimes of backing up your data, I think that's very important, especially when it comes to data that is you can describe to be pertinent to your users. I think having regular regimes of backups, and maybe if you can do those backups on an instance or a different server environment than the one that your current application is working. I think I think that is important. It has helped us once or twice. We were not attacked per se, but it was more to do with there was an update. There's a time MySQL, for whatever reason, released an update, and then it caused an issue with the operations. And then the other thing I would say, especially when it comes to security, is I think to go back to what Ogboy, Samuel, my brother, what you're saying, not trusting what the client is going to do. I have seen this, especially when it comes to I don't know if I should call them edge cases, but there are some instances where you are not able to anticipate what a user is going to do. Even in your test cases, you've not factored that. So I've seen, they are not really malicious, but in fact, I was really interested, with how they were able to do that. And then I learned it was like an edge case. It is something that I think maybe I was too lazy to work around. So yeah, basically I think those are the things that I'm able to share at the moment, because I feel like most of it has been discussed. Thanks, everyone.
Thank you so much, Brian. I think your input was very helpful, and even just reiterating some of these points, I think is important because you get a different perspective on some of these points, although they might seem similar, and I think that's still very, very important. I'm glad you mentioned the Safaricom callback URL, and in a case that I had never thought about, where somebody might exploit that callback URL, because if I think about it now, it's very, very much exposed because you have to leave that endpoint open for Safaricom M-Pesa to notify you that a payment request that you had sent has actually been received and has been processed. And the way they validate that is by sending you a payload. And it's long since I did the Safaricom SDK push. I think I did it for a service like maybe 2 years ago. I don't know which kind of security mechanism, or rather I can't remember which kind of security mechanisms they have in place to at least validate that payload. Maybe it's like a security key that you send them together with your SDK push request. I think it's called an LNMS request or something. LNMS result. I think that the LNMS result is what they send you back after you tell them, send this request to the customer for a payment. Then when the customer approves the payment and payment goes through, they're supposed to respond to you with a payload to the endpoint that you provided them. I can't remember, but if anybody in the space has integrated Safaricom Daraja API, SDK push, maybe you can tell us whether at least there's some key that you're able to share with them so that when that callback URL comes, you can actually validate it. Because I agree with you, somebody can just send you some payload and it's not the correct payload, but they can just send you some payload that approves a payment that didn't go through. And since you've automated all these things, then your service will continue to process this as a valid payment. And I think there can be potential abuse. I think even just leaving that endpoint open, even if somebody is not using it to validate a payment that's malicious, they can still use it to do things like SQL injection, or sending you some script that you think is part of your request. Then you if you're not doing, I think Habbes mentioned having prepared statements. If you're doing direct SQL queries on your database, then you execute some malicious script expecting to be a callback from a service, such as Safaricom M-Pesa. So yeah, I mean. I think it's worth thinking about that endpoint, and also looking at on the Safaricom side which kind of security practices they've put in place to make sure that they don't expose you if somebody figures out, because you send the endpoint together with your request for the SDK push. So if somebody intercepts that, gets the callback URL that you're giving Safaricom, then they can just send you a payload on the endpoint that you're providing to Safaricom. Although it will require some sophisticated hack to figure out the callback URL you're sending, because you are the one who provides it to Safaricom. But I have to agree, just having that endpoint open already is an issue. And I think that brings me to another point in I think API security, the concept of I hope I don't butcher the pronunciation of this, independence endpoints, where if you have a safe endpoint like a get endpoint, that get endpoint should not mutate your service. So you should not use a get endpoint to register a new user. You should not use a get endpoint to validate a payment transaction. So I think that's one concept to establish. I think at least for the callback URL, it has to be a post endpoint because they are sending you a payload. But some developers might make, because GET requests can still receive payloads. So some developers might make the mistake of leaving that callback URL open to like a GET endpoint that accepts a request that might end up mutating the nature of the system. So Habbes, I think I'll give you the mic. There's one correction that John Doe has made on the replies there, and I welcome these corrections that we're able to get the correct information. Although this is semantics, Stanley. So Stanley corrected us on, or corrected me specifically on SHA-1, SHA-256, and MD5 are discouraged as password hashing mechanisms, but they're not necessarily discontinued. It's not like you can't use them, but they are discouraged. So I have two hands raised. So I think I'll start with Habbes because you are first, and then we'll go to Brian. Yeah, the mic is yours.
Thanks. Just wanted to add some clarification or to add an addition to the idempotence point that you made. So yeah, I think the main key about the idempotence is that if the same endpoint is hit multiple times, the effect should be the same as if it was hit once. So for example, and this applies not only to GET, but also to even to post requests and whatever. So for example, if you have a webhook that is supposed to verify a payment, and this webhook you implemented in your server, it actually changes the state of your server. So it's not just that it does not change the state of your server, it may change the state of your server, but if the same webhook is hit again with the same payload, it should not like change it again. Like so for example, because what would happen is sometimes the API provider can actually send you multiple webhooks to verify the same payment. Maybe sometimes they may have this this case where, let's say they send you a webhook. If you don't reply within a certain period, they might assume that maybe you failed, maybe it was a timeout, you failed to process it, and maybe they can decide to send it to you again just to make sure you received it. So your service should be implemented in such a way that if you were to receive that multiple times, you should treat it, it should not be any have any different side effect than if you had received it once. So maybe just make sure like you keep track of maybe the status that you have set for a particular ID, or have a way to kind of cache that you've already processed a specific request or a specific payment, such that if you receive the same message again, you know that you have already processed this, and so you don't need to process it again. Yeah, so that's maybe I thought was important to add. I think the other thing about webhook URLs is some APIs give you like the ability to add a secret, to configure a secret that is going to be sent to the payload that they're going to send to your webhook URL, and then you can use that kind of secret to verify that the webhook URL came from that specific endpoint, specific server. You can also check the URL of the request, the remote URL of the request. Another thing that I like to do is I like to inject like a secret in the path that I set as a webhook, and this secret is not a secret in the path that is not part of the source code, and maybe I have it in an environment variable or some other place that now when I'm generating the server endpoints, I generate an endpoint with a variable path which contains a secret, and that secret I'll configure it to the API. And so if I have different environments of the API, like a staging or a like say a sandbox API and a server and a production API, I can use different webhooks URLs without actually having to change my code because the URL is not actually in the code. So that's maybe another tip that may help.
Oh yeah, I mean, thank you so much for pointing that out. I think also Stanley has pointed it out in the comments, and yeah, he mentions that, and I quote, "My approach to the Safaricom callback URL is to make it dynamic using query parameters. You can include anything there, including API keys. So maybe you have a URL, question mark API is equals to a query param such as foo, and then on the service, I think, yeah, that can work fairly well. I think Habbes, your strategy also is good where you're injecting some security keys so that when you're getting that callback URL, at least you can validate that this is the thing that I sent to the service, and when I'm getting this response, I can actually validate that at least to some probability. You increase the probability of it coming from the legitimate service because since you are sending the payload with the callback URL, if somebody is able to figure out the payload that was sent out for that particular SDK push, maybe they figure out your strategy of generating this special query params, maybe. But at least now it's on the maybe level, so you don't just have a static callback URL that once somebody figures out that all the requests are going to this particular endpoint and it's always this URL type, then they can go ahead and abuse it. So I think that's some really good strategy. I think it can work. This webhook issue is very common. I think for a lot of APIs that you consume as a server-based client, if I'm able to call it that, you'll likely have to use a webhook, especially if you want the other service to trigger some event that might happen in future, like in the Safaricom case where the customer might validate that transaction a few seconds or a few minutes later after the request came in. I know for Africa Stocking, when maybe you want to receive, use their service for SMS delivery, and you also want to receive SMS short code responses from maybe customers or something like that, they also use a webhook. A number of services use this strategy, so I think it's good that we've discussed a bit of how you can still ensure the security of your system. Oh, and thank you for talking about the Idempotence case there. I think within HTTP there are some methods that are just considered idempotent. The get, put, and delete methods. The post method is a destructive method because it by definition it will mutate your server because it's bringing in new objects to your backend. But I like that even for that you will consider an engineer to figure out a way to make that independent, so that if somebody sends me a payload, I process it. If and I receive another payload with the same signature, with the same data, then I should not use it to modify the state of my service. Although I think from a back-end engineering perspective, that would take a bit of ingenuity and some ideas on how to be able to establish independence on post endpoints. But I think it's something interesting to think about. Otherwise, I think that's also an important security issue. So Brian, let me hear from you.
Oh yeah, I had forgotten to mention this. Safaricom, after some time, because I think some of us raised it, they have a way of you can, with the transaction code, you're able to sort of, ask them, is this transaction code valid in a sense? Is it for this amount that this client is claiming to have paid? And then now they return, true or false. So maybe that might, because what you have said about dynamic, the callback should to be dynamic. I think that is also another way of handling that, because once you receive the payload, you can be able now to check if that transaction code is valid or not. Sometimes people, actually most of the transactions, you'll be surprised, are not on STK per se. They are just direct C2B. C2B. The STK instantiation is, in fact, some of the SIM cards, I think you need to update. So people, for whatever reason, like typing the pay bill and the sort of account number. In the case of M-Pesa, that is. But now there's that. They have a way of you verifying if that transaction, using the transaction code, if it actually happened. So I thought of mentioning that. So like in a way, they tried to work around it. They're actually good. If I'm to give, there's a lot of bad PR about or bad press about Safaricom, but when it comes to M-Pesa, I'd say that they are they are okay. They are okay.
They're trying. Yeah, I mean, you have to give it to them. I think M-Pesa is a formidable service. I remember back in campus days where the Bonga Point service kept getting hacked. I don't know if it was fraud or actual, cyber attack. And, you'd get these cases where people end up with the 10 million shillings worth of airtime overnight. I think it was just some loopholes within their system, or just employee fraud, which is something that I think they're dealing with currently. I think it has gone to a point where it's even affecting the employees. So I was just looking at their fiscal report yesterday, the day before yesterday, and one of the things on the report is I think the number of employees they've had to let go due to fraud has increased by, if I'm right, it has increased by like 31%, or they were able to send out like 30 employees. I can't remember the actual structure of the report, but I think it ties into what Collins had mentioned. There's some common sense organizational things that you have to put in place. Like Safaricom and M-Pesa should know that they are running a really sensitive service, and some employees might come in, and once they've established their roots there, then they start exploiting that service, and becoming the point of entry for attacks, and sometimes not even cyber attacks, just social engineering, and people figuring out loopholes and using these employees as a way to get into the system. But bottom line, Safaricom is, I think they're formidable when it comes to security and stuff like that. I'm glad that they've made steps also to do some security on the callback URL that they request from developers when doing SDK push. And I've never explored the C2B where somebody does a pay bill and then they let you know that you received this and this is a transaction ID so that you can automate it on your backend. I think that's very interesting. Maybe if I'm ever doing another service, I think that's one thing I'll explore. But yeah, I mean, I think it's interesting. We've discussed this, and it stretches beyond just using the M-Pesa Daraja API. I think any service that provides a webhook or a callback URL, I think at least now we know there's a way you can at least do some common sense type security for that endpoint, so that it's not too easy for somebody to exploit it. And I think that's a great step forward. I don't know if there's anything else I could touch on. Is there anybody else who would like to add to the discussion? I think we've heard from Samuel Ogoboy, Habbes, we've heard from Brian, we've heard from Collins, and Elizabeth. I don't know if you're still able to chip in, but I think we've been able to learn quite a bit from at least the people who were able to join. It's kind of late. Here it's 10 p.m. So I think if there is nothing else, if it's okay, I do a round of final comments from the people who offered to speak. Maybe just give your final tips or just your final words as we end the space. But before we do that, I'd like to thank all of you for coming to the space, for joining us for this discussion. And I think it's always good for professionals to have such a forum. I'm one of those bedroom developers, as they call them nowadays. So I don't interact with people much, apart from the team that I work with. So I'm always anxious about what are other software developers doing, what could I learn from my fellow peers without having to, take time off my schedule and go to these tech events. I love tech events, but I work in a startup and it's early stage, so it's very difficult for me to just say, oh, I'm going to take these 3 days and I won't be able to deliver this and this, and at that time I'll be out of the office doing some other things. So I think having a forum like this, and that's actually the reason why I ended up creating it, is so that we can have a space where we discuss these issues and we learn from each other. I think from the previous space, I mentioned that we should have a boring discussion site. When we are done, you can open your IDE and maybe edit one line of code. Like the callback URL thing we've discussed. You can go and plug in a query param to one of your webhooks, and you've already applied something from the space. And I think that's the goal. If you can achieve that, I think that can be very interesting. Otherwise, I thank you so much, guys, for joining. I'd like to hear from the guys who offered to speak and get their final word before we close. So if it's okay, Samuel, I would like to start with you. We just give a brief final word, and then we can end the space after we hear from the others.
Okay. Can you hear me?
Very, very well.
All right. Thank you so much. I really appreciate it. It's really been a brainstorming, great session. The final note is just that we should be aware about what's going on in the community and the tech space. Technology is advancing in the good aspect, it's also advancing at the bad aspect. What I mean by bad aspect is that attackers, bad guys, the technology also advancing. So whichever stack we use, whichever framework we use, let's make sure that we are always which of the framework, which of the packages are obsolete, and we upgrade, we patch, because all these packages they release security updates and get updated. And maybe you are there, maybe you are also into DevOps, trying wanting to manage server. Server is a critical point. That's why all the resources are being stored. So that's like a big gate to the to the treasure. So it must really, really, really be preserved, so that the attackers will not be able to gain entrance. And even when they gain entrance, they will not be able to perform a disastrous activity. They will not be able to do anything with anything they get, even when they gain entrance. So when we put this at that, I believe it will really help us to make a more secure softwares as we progress. Thank you so much. I really appreciate the opportunity.
Thank you so much, Samuel. I hope you join us on the next one. We should do this on Fridays at 8 p.m. So I really appreciate your input.
Okay. All right, I'll put it at that. Thank you.
Okay, see you Friday. Let's hear from Habbes.
Yeah, well, thanks for setting this up and thanks for having me on the call. Maybe just one tip I would add is, it's not always easy to have all these consideration when you're developing code. What might help is if you have someone that you can take through your architecture before you get too far in development, and they can guide you on help you find security black spots, which is part of like the threat modeling that the host mentioned. And you can also do that before like deployment. You just do an audit. If you don't have someone internally, you could maybe find like a consultant who's like an expert in the field, and they can help you like do an audit before and after, just to make sure that you've kind of considered like security concerns that you may not even have been aware of as a developer.
Thank you so much, Habbes. I think that's a very important point. And if you don't have somebody, you can join this space and hear from people that maybe are too geographically away from you. But it's always important to have somebody look at your architecture, look at your code up to every single line. Look at your security policy, look at your, like we talked about password encoding, how you're storing the password. You might be encoding them correctly, but you are storing them on an insecure server. So stuff like that. So it's always important to have that second perspective. And I really value that. And just like I mentioned, that's one of the reasons why I decided we have this sort of space where, you can get a few nuggets of wisdom, small things that you can act on immediately. And I'm glad that on today's space we were able to achieve that. Thanks to you, Habbes, and the other people who offered to speak. So thank you so much. I hope you join us also on Friday. I'll share the topic either tomorrow or Sunday for next Friday's meet. And I hope to have you. We were supposed to have you on the performance tuning one. But I had already put in a list of other speakers. But we'll do another performance tuning round, either in the 4th or the 5th installment. And I think judging from the kind of wisdom you've been able to share regarding security, I think it will also be interesting to hear some of the tips and ideas you have around performance tuning. Otherwise, thank you so much for joining. So Brian is not, you're not our guest here. So let's hear your final word and give us maybe a few tips and also thank you for joining, Brian. But let's hear from you.
Oh yeah. I was not a speaker. I just randomly popped in, and then it's quite interesting that you've said that I don't know, what have you said? Bedroom. There's that term that you've said.
Oh yeah, I saw it in the timeline. It's called a bedroom developer.
Yeah. And I don't know. The other day, I think I told you should consider holding a JavaCon at one of the Java restaurants. Okay, it's a play of words. I think these kind of forums are important in that you like there are some explanations or descriptions that I don't know how to put this. Like they are not search engine friendly, but on forums like this, they become almost organic because it's conversational, and you can easily make references at your own time. So yeah, let's continue building more secure systems. And thanks for everyone who joined and listened in.
Thank you so much. Thank you so much, Brian. Collins, thank you for joining. If you don't mind, maybe you can share just maybe one final tip or a final summary or something you found interesting from the space, and I think from there we can consider closing. Collins, are you there? Okay, I think we may have lost Collins, but thank you so much, Collins, for coming and sharing your nuggets of wisdom. And I think the people who joined the space really appreciate that. And I think coming from this space, at least we've learned a few things that we can put into practice, and a few things that we need to research on. Like there's a lot that I was in the weeds about. So after this, I'll be looking through a lot of docs, trying to figure out, how does this really work? And I think the spark comes from hearing it about it from you guys. So thank you so much, even the guys who contributed on the replies. And let me just see if I missed any comment, any reply. Elizabeth, also thank you, although you are not able to speak, but I hope you'll be able to speak on the next one. But thank you so much for joining. Let me see if there's anything on the replies that that I may have missed. Then I think we can close. Okay, so Stanley has shared something about CQRS. Pattern that can help prevent duplication of operations in CQRS. There's a doc he has shared there. I think that would be very useful. I think it ties into our discussion on idempotence. If I'm pronouncing that correctly, I'll look for the correct pronunciation. You can check that out. Dr. Natkes also shared a lot on the replies, talking about investigation, detection, and the response to breach. I think next time I'll try and get a cybersec professional who just does cybersec, so that we can talk about things like responding to a breach, network layer security, and what I was interested mostly is getting someone from the cybersecurity front giving us tips as software engineers. I think that would be an interesting mix. So it's something that I'll work on, and I hope I'll be able to figure that out. Otherwise, I think that ties it in. The conversation can continue in the TL, and I'd like to take this moment to thank you very much, guys, for coming. And we do this every Friday, 8 p.m. So I hope to see you guys on the next one. Thank you so much for joining.